Welcome to Regents Math Episode 2. I should write that somewhere actually. This is Episode 2. Episode 2 right there. And yeah, so I guess we should get started on some readings. I don't even know what test this is. I'll let you know in the video description below. But let's just get through as many test questions as possible because our school year ends in 2 days. And the Regents is more than a week, almost 2 weeks away. So now is the time where we just grind through problems as much as possible, get through as many tests as possible. So here goes nothing. I don't even know something about my computers, USB drives and everything. It's kind of weird. So I have to work with the built-in mic. So if my voice is a bit lacking in quality, I apologize. The recording screen itself, however, should be fine. So, Julian plans on drawing ABC where the measure of angle A can range from 50 to 60 and B can range from 90 to 100. Given the conditions, what's the correct range measure possible for angle C? Well, we do know that we're talking about a triangle here, and a triangle has 180 degrees. So if angle A has from 50 degrees to 60 degrees, right? And angle B has from degrees 90 to 100, and everything adds up to 180. So we can just take the minimum values of both angles and subtract it from 180. And the maximum values from 180, and that would be our answer. So let's take the minimum values of both first. So 50 is the minimum value of A, and 90 degrees is the minimum value of B. So 50 plus 90 is equal to 140. And we'll subtract 180 from that to get the smallest angle possible for measure C, which would be 40 degrees. So that's our first vantage point. Actually, this would actually be the maximum for point C. Actually, since we're taking the smallest here, angle C must be the largest. Yeah. All right. So moving on. Anyways, now we take the maximum values, which is 60 and 100. So 60 plus 100 would be 160. 180 minus 160 would be 20 degrees, so 20 would actually be our minimum value, and that's kind of common sense. If your two other angles are pretty big, then your third angles are going to be smaller. So yeah, so 20 is our min value for C, so angle C is going to be from 20 degrees, and this is C, let's call that C, to 40 degrees right there, and that's going to be our answer. And if we look for it in the answer sheet, boom, right there. Choice number 1, 20 degrees to 40 degrees. Alright, moving on. Alright, question number 2 says, in this diagram shown below, AB is congruent to DE, so that's congruent. Angle A is congruent to angle D, and angle B is congruent to angle E. So let's just mark that. What method can be used to prove that this triangle right here is congruent to that triangle right there? Well, let's just follow the marks that we made. Here we have an angle, follow it to a side, follow it to an angle, angle, side, angle. So it's an angle, side, angle, congruent to angle, side, angle. Right there, choice number 3. Easy peasy. Alright, question number 3. In the diagram below, under which transformation will A prime, B prime, C prime be the image of triangle ABC? Well, let's see. We're going from this triangle to this triangle right here. It looks like, I don't know, there isn't really any mathematical trick here. You just have to use your brain a little to figure out that, hey, if I rotate this 180 degrees, it's going to come up with this triangle right here, a rotation of 180 degrees. A translation, it's not going to fit because it's going to look kind of like that. A glide reflection is going to be like a translation followed by a translation followed by a reflection, and that still wouldn't match because it looks kind of like that. And a dilation, it just enlarges this thing, so it's obviously not it. So that's number 3. Number 4, the lateral faces of a regular pyramid are composed of. Okay. A regular pyramid. Well, let's try and draw any regular old pyramid. I'll draw a square pyramid. Please hold while I draw. And I guess I'll use blue for the back. So pretend that the blue is like the back of the triangle and the red's the part that we can see. So the lateral faces are the faces. They're not the bases. This thing right here is the base. And these are faces right here. So the faces, obviously it's a triangle. It is a triangle that looks like that. And now we need to know what they are. Well, it's definitely not squares and it's definitely not rectangles, so you're left with 2. So are they congruent right triangles, or are they congruent isosceles triangles? Well, just by looking at it from this diagram, you know that it's not a right triangle, and you can probably come up with answer 4 right here, and you would be correct. But let's think why it's true. Because let's see how to explain this. Since all the sides are going to a common point and they start from the same, I don't know, it's a regular pyramid, so all the sides of the base are the same, so that means all the vertexes here, 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 and here are equidistant, so when they go towards that top vertex, it's going to be the same length, and that's why it's an isosceles triangle. This is another common sense problem. It's not really meant for you to overanalyze or anything. So that's number 4. Question number 5 says point A is located at 4, -7, and the point's reflected in the x-axis. So its images located at, well, this is just one of your rules. What is our x-axis of x, y? This was one of our first videos. It's just x, -y. You just flip the opposite variable. So 4, -7 would translate to 4, +7, choice 3. Done. Okay, question number 6 says in the diagram of circle O, chords A, B, and AD are parallel, so I guess we should mark that. And BD is the diameter. Okay. If AD is 60, then what is CDB? Alright. Well, this is very not to scale, but one of our circle rules is that if you have an angle inside the circle, an inscribed angle going to an arc of the circle, then that arc divided by 2 is that inscribed angle. So this angle is 30 right here, and that's one of our circle rules. And since these are parallel lines right here, A, B, and CD are parallel lines, and they're cut by a transversal, which is BD. BD is a transversal here. Let me mark it for you. That's a transversal right there. The rules of parallel lines and transversals apply. So alternate interior angles are congruent. So angle, wrong tool, angle BDC is 30 degrees. So or CDB rather. So, yep, the answer, not 1, sorry, it's 2, 30 degrees. Okay, the Regents exam loves giving these types of problems. You will always see this type of problem in your Regents exam, whether you like it or not. So, this is important. What's the equation of a line that passed through the point -2, 5 and is perpendicular, keyword is perpendicular, to the line whose equation is y = 1/2 x + 5. So we have to write the equation of a line that passes through that, but it's perpendicular. So the slope must be the negative reciprocal of the equation that they actually give you. So we're not going to focus on this plus 5 here. We'll just cross that out. We don't need it. But this 1/2 x here, we need that. 1/2 x. Because we need the equation of a line that's the negative reciprocal of that. So if the slope is negative, if the slope is 1/2, then the negative reciprocal would be just -2. So our slope for the equation of our line is going to be -2. So I guess you can cross out this and that leaves us with two choices. Now you're going to ask, how do you know which one passes through the point 25? You could either do just substitute these values into both of these equations, and whichever one's true is the answer, obviously. We're actually going to do that way, just in case you forgot the point slope formula, but I'll do the point slope formula anyway later. So this is -2 times -2 plus 1, -4 plus 1. Alright, so this isn't good, but this is 5 equals -2. -2 minus 9, 4 minus 9, -5. Wait, I'm doing something wrong here. What is this? Oh yeah, this. Gosh, I'm an idiot. Alright, so choice 2 is -2x plus 1, right? So y is 5. This is -2 times -2 plus 1. This is 4 plus 1, so that's 5. Alright, so -2, 2 is the right answer. Sorry. Doing this live is pretty hard because I don't even know what I'm saying half the time. So, alright, so that's the substitution method. But you can also do it the point slope method. So if you know the point slope formula, which is y minus y1 is equal to m times x minus x1, and this is what they're testing you on in reality. Just substitute this point in, -2, 5. So y minus 5 is equal to, and our slope is -2, right? -2 times x minus -2, or positive 2 here. So y minus 5 is equal to -2x minus 2, add 5, so your answer would be y equals -2x plus 1, because I just screwed up there. See, I don't even know what I'm doing half the time. Whatever. Okay, so this is a big one. Number 8, after a composition, the coordinates of blah 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 become that, shown on the set of axes. What composition was used? Okay, so we're going from this to there. The first thing you'll notice is that the resulting triangle is smaller than the triangle that you start off with. So you know right away that a dilation is involved here. It's a dilation, and it's probably a dilation that shortens and makes the triangle smaller. So that's going to be probably a dilation of 1/2, but we'll have to see. Alright. So, and also it looks like a rotation of 180 is required. So let's test that. By the way, composition, you don't read it from left to right, you read it from right to left, so don't be fooled by that. You always start from the right and you work your way left. So, I don't know, from my guess, it looks like it's a rotation of 180, and right after that, it's going to be a dilation, halving the size of it, so it's a dilation of 1/2. So if we're going to write that in composition form, it's going to be d1/2 circle r180. So is that one of the answer choices? Yes, number 3, but let's just test it to be sure. So if it's r180, I believe you're just going to make both values negative, right? So if A is 4, 2, then A after the rotation of 180 is going to be -4, -2, and then B prime is going to be -4, -6, C prime is going to be -2, -6, cool, and then dilation of 1/2. Dilation of 1/2 is just going to have all this, so A double prime, -2, -1, B double prime, -2, -3, C double prime, -1, -3. Does that match up? Yep, matches up, matches up, matches up. We're good here. Okay, number 9, and we're gonna go up to number 14 in this video. In an equilateral triangle, what's the difference between the sum of the exterior and the sum of the interior? Okay, so we know that every single, in any polygon, the sum of the exterior angles is 360 degrees. That's just a fact. Memorize it because it's going to come up on the Regents. It's just applies to every single polygon. The sum of the interior angles is, you can find that out by 180 times n minus 2, right? So a triangle has 3 sides, so it's 180 times 3 minus 2, which is 1. So triangle is 180 degrees, which you already knew. Alright, so, and they're asking for the difference between it, so that's going to be 360 minus 180, which is just 180. What the Regents also loves to do is give these circle equations. So, what's the equation of a circle with the center at 3, -3, 5? Okay, so an equation of a circle is always going to be x, whatever, and then plus y something, and both these terms are squared, is equal to the radius squared. Okay, the rule for what you put in this thing is going to be the opposite of the variables you're given. So in this case it's -3, 5, and -3 is your x, right? So just flip it. So flipping -3 would just be +3, right? So that's what you're going to put on here. And for the y, it's 5, right? So just flip it, it's -5, just put -5 in here. That simple. And then radius is 4, and if r squared is 4, wait, am I doing this right? Radius of 4. Oh yeah, so this is r squared, right? So if we're going to take the square root of both sides, it's going to, wait, oh my god, what am I doing? Alright, so the radius is 4. Sorry for confusing you. So it's going to be 4 squared, so that's 16. So the final equation is going to be x plus 3 squared plus y minus 5 squared equals 16. Okay. Okay, choice 2. Phew. I've been doing this for like 30 minutes now. Even if you are only watching like a 15-minute video, I'm doing this for much longer, so my concentration, man. Alright, moving on.